Okay, Math at Work 11, this is your next video on the trigonometry chapter. So we already did a video reviewing how we use trigonometry to find missing sides and missing angles. So we're going to be using that today in conjunction with a few different terms and definitions, okay? So today we're going to be looking at angles of elevation, angles of depression, using those to kind of set up triangles, draw triangles, and go from there. All right, so let's get started. Alright, so like I said, what we're going to be looking at today is focusing on some key definitions of what we call the angle of elevation and the angle of depression. Okay. The other thing you'll see peppered throughout different textbooks and stuff would be the other term called angle of inclination. So angle of inclination and elevation are oftentimes interchangeable, right? They essentially just mean the same thing, okay? So you'll notice in those definitions, the angle of inclination of a line segment is the acute angle less than 90 degrees that it makes with the horizontal. Okay, so it's just an angle from a line going to another line, but one of those, the first line is the horizontal, right? So the horizontal and then going up like an incline, okay? When we talk about an angle of elevation, you'll notice that the definition is almost identical, right? The angle of elevation of an object is the angle between the horizontal and the line of sight from the observer object that is going up, right? So what that means is that if you were looking straight, right, that's a straight horizontal line, and then you angled your eyes up to look at something, the amount that you angled your eyes up is considered the angle of elevation, okay? So the big thing with angle of elevation is it's always from the horizontal straight line, right? So it could be from the ground, right? If you were lying on the ground and angling your eyes up to look at the top of a tree, that would be an angle of elevation of how much you lifted your eyes up, right? Or even if you were standing up and you were looking straight ahead and then lifted your eyes up to look at the top of the tree, okay? From the horizontal, from the height of your eyes, and then angled up, that's the angle of elevation, okay? Conversely, you've got the angle of depression, okay? The thing that's similar between them is that they are both things going from the horizontal, okay? So from a straight line, an angle of elevation is looking up, but an angle of depression is if you were looking straight and then looking down, okay? So that distance, the angle between the horizontal line of sight and then angling down to see that object, right? So you'll see angle of depression a lot more when you're looking at problems where somebody's like high up on something, right? You might be standing on the top of a house and you need to look down at something on the ground. So if you were just looking straight ahead and then you angled your eyes down until you saw the object on the ground that you're looking for, how much you angled your eyes down would be considered the angle of depression, okay? So again, both from the horizontal, from looking straight. If you were looking up at something, how much you angled up is angle of elevation, how much you angled down is angle of depression. Okay, so with this stuff, there's no real new math to it. It's just using those definitions to be able to come up with the diagram or interpreting the diagram using those terms of angle of elevation and angle of depression. Okay, so we're going to be performing similar calculations for finding the missing side length or the missing angle. Okay, but now you're going to have some context, right? So it's the same steps, right? So if it's a missing side length, draw your diagram, and that's going to be a lot more important now if you're being described things about angle of elevation and depression. You need to make sure you're drawing it in the right spot. Fill in those known angles, label your triangle using opposite, adjacent, hypotenuse, determine the trig ratio, right? Set up that equation, and then solve for your missing side length or your missing angle, okay? So same thing. So we're just going to run through some examples on this now. So here's example 1. So Natalie runs a scenic chairlift ride that overlooks part of Marble Mountain, Newfoundland. Tourists get on the chairlift at the bottom and take the 1,800-meter long ride up the mountain. The cables that the chairs ride have a 36-degree angle of elevation. A tourist wants to know the horizontal distance the ride travels. What is that horizontal distance to the nearest meter? All right, so let's work on this. So again, step 1 would be trying to draw this diagram. Okay, so I'm reading this. We get on a chairlift at the bottom, and we take an 1,800-meter long ride up the mountain. Okay, so by setting that up, so here we get on the chairlift, and we're going up the mountain, and the length of the ride is 1,800 meters. Okay, we're also told in the question, right, if we kind of flip back and forth a bit, the cables that the chairs ride have a 36-degree angle of elevation. Right, so again, angle of elevation, what we just defined is that was from the horizontal, so this is where we get on. The horizontal is that straight line going across, and then we angle up 36 degrees. Okay? And it says the tourist wants to know Tourist wants to know what's the horizontal distance of this ride. Okay, so how far would they have gone this way? Okay, now the height of the ride, you might know if it goes up to the total top of the mountain. But if you were trying to measure this, we'd have a problem because you'd have to dig underneath the mountain to be able to get that distance. So we can't just take out a trundle wheel or something and measure it. We actually do need to use trigonometry here. Okay, so this would be where our right angle is. Okay, and then we do the same math what we were doing before, right? So we set up our, we got a triangle set up. That's our right angle, so that means that this side is our hypotenuse. This is the angle of elevation we've been given, so this would be considered our opposite side length, and then down here this would be considered our adjacent side length. Okay, so we're interested in this value right here, so I'll call that x, right, the unknown that we're trying to find. So I have the hypotenuse, I'm looking for the adjacent, so the trig ratio that involves adjacent and hypotenuse is cosine. So I would set up cosine of theta is equal to the adjacent divided by the hypotenuse. I have the angle value, it's 36 degrees. Cosine of 36 degrees is equal to x, the unknown adjacent, divided by 1800, which is the hypotenuse. Okay? And then to get rid of this fraction, you always multiply both sides by the denominator. So you're going to multiply both sides by 1800 here. Right? So if I times this by 1800, it cancels out there. And I'll times this by 1800 here. And what I get from my calculator in degree mode, cosine of 36 times 1800, and we get 1456.23 meters is equal to x. And I believe the question did actually ask for the nearest meter, so we would just round that down to 1456. Right, so 1,456 meters is the horizontal distance that this chairlift goes underneath the mountain. Okay? All right, so again, you see the same thing here. Like, this is one of the textbook questions, right? You see the diagram, all that stuff, right? It's traveling up a slope, the horizontal distance under the ground. She needs to use trigonometry to figure out that value. Okay, now again, like I said, if you knew the height of the mountain, you could again just use Pythagorean theorem, but you're still using an aspect of trigonometry, right? But if you don't have that particular height and you have the angle instead, the angle can be used. All right, let's look at a second example. All right, so this one's going to be using an angle of depression. Okay, so Emily is touring historical lighthouses in Nova Scotia. While she is at the top of the Peter Island Lighthouse, she notices that she can see Sweet Cake Cove across the water to the southwest. The lighthouse is 13 meters high, and its base is 19 meters above the water. Emily estimates that she looks down at the cove with an angle of depression of 5 degrees. What is the approximate horizontal distance from the lighthouse to Sweet Cake Cove to the nearest meter? Okay. So what we would need to do again is start by trying to draw this. Okay. So just kind of reading through there. So she's at the top of this lighthouse, and she can see Sweet Cake Cove somewhere else, right? So if we kind of general idea here, right, is we're standing at the top of this lighthouse. All right, so we have our lighthouse here. She's standing up here, and she can see this Sweet Cake Cove over here in the distance. All right, we've been actually asked, okay, well, how far, what's the horizontal distance from there to there, right? This is our unknown value, okay? The question also states that the lighthouse is 13 meters high, and its base is 19 meters above the water, okay? Well, a cove is in the water itself. So it might be that this is where the lighthouse starts, right? Oh, you're not seeing that, okay? There's 19 meters above the water, right? And then you've got your lighthouse here, right? So again, reading that question very, very carefully, we're seeing there that the lighthouse is 13 meters high, so one section of it is just that, and the base of the lighthouse is 19 meters above the water, okay? So again, if this is the water, right, we've got to go up 19 meters to even get to the base, and then the actual lighthouse, right, is here. I can't draw a lighthouse, okay? So if we're talking about the actual height, right, how tall is Emily standing above the water, right, above the cove, it would be a distance of this 19 meters plus this 13 meters, right? So we'd add those two together. 19 and 13 make 32. So combined, this height is 32 meters. Okay. Now it says in the question as well, right, we keep kind of going back to it, she estimates that when she looks down at the cove with an angle of depression of 5 degrees. Okay. So again, when we talk about angle of depression, it's from the horizontal looking down. So if this is where Emily is here, if she's looking straight, this is the horizontal line looking straight, okay? And then she's going angle of depression from the horizontal going down, right? So she angles her eyes down 5 degrees, okay? So notice that that 5 degrees is actually outside of the triangle right now, okay? So if we're actually going to solve this triangle, we need one of the angles inside the triangle. So there's two options that you have here. One is reimagine your triangle upside down and use the 5 degrees like this, right? And then that's your 90, and then you kind of create a rectangle where this 32 is the same as this 32 here, right? And then don't worry about this section, and just instead think, okay, there's my 5 degrees, there's my 32, I'm solving for this length here, okay? There's option one. If you don't like that, the other thing you can do is just use a basic angle property here, which states that the sum of the angles, right, this would have created, since this is a horizontal, this is straight up, this would have been a right angle altogether. So if this is 5 degrees on the outside, these two angles will have to add to 90. So if this is 5, this angle in here would have to be 85, so you just subtract it from 90, okay? Right? And then what's actually interesting about doing that is you'll notice that the sum of the angles in a triangle adds up to 180, and if you do 180 minus 90 minus 85, you actually get this 5 degree angle down here, right? So there's kind of that relationship between an angle of elevation and an angle of depression. You need to make sure that you're correctly drawing your diagram showing an angle of depression so you understand what that term is. But there is that relationship because if this horizontal line is parallel with this horizontal line, this is a particular angle property that says that these two angles will actually be equal. Okay, but either way, pick the method that you like the best. Okay, the one that makes sense for you. But if we were going to do this, and I decided to use the 85, I then am ready to start setting up my trig ratios. Right, so there's my angle, which means this is my opposite side length. This is my hypotenuse because it's directly across from the right angle. And then this is my adjacent, okay? So looking at that, I have the adjacent, I'm looking for the opposite, so that's a tan ratio, right? Tan theta is equal to opposite divided by adjacent. So the angle in question I'm using here is tan of 85 degrees is equal to x, which is my opposite, divided by 32, which is my adjacent, right? Again, I'm solving for x, so I want to get rid of this fraction. So whenever you're dealing with fractions, multiply both sides by the denominator. Right, so multiply that side by 32 and multiply that side by 32. Right, and then this can just be done straight from the calculator, where you can do tan of 85 times 32. Okay, that came off your Lego. Okay, we'll fix it later, okay? Okay. All right, so tan of 85 times 32, and you get a value of 365.76 meters is equal to x. And if we quickly go and check the other, the question again, nearest meter. So if it's nearest meter, we're going to be rounding that value up to 366. Okay? And that would be your answer. Again, like I said, you could have solved this slightly differently and chosen to use this as your 5 degree angle here, right, and not worried about the 85, but if you did that, you'd have to relabel your triangle. This can still stay the hypotenuse, but now this becomes the opposite side length, and this becomes the adjacent. You're again still using tan, but you'll notice that the setup becomes tan of 5 degrees is equal to 32 divided by x. Right, and this is what I would consider what we call a two-step trig problem, where you would first have to multiply both sides by x and then divide both sides by tan of 5 degrees, where you'd have x is equal to 32 divided by tan of 5. And if you did that, 32 divided by tan of 5, you still get that same value of 365.76. Okay, so you get the same answer either way. All right, but that's another question dealing with angle of depression. Okay, so yeah, again, you see that same thing right there. You're looking at the sum, right, the 19 plus the 13. There's that angle of depression that's from the horizontal looking down. And so I think the way the textbook did it is they used that upside down triangle, right, making it a rectangle. But like I said, you can also use that angle property to have these two angles add to 90, okay? And there you go, right? And in that sense, you had to do that two-step trig problem there, where you had to multiply both sides by x and then divide both sides by tan of 5 degrees, right? That both ways work. All right, let's take a look at our last example, okay? So with this one, we've got Lori is a crew member on a tall ship that sails the Bay of Islands in Newfoundland. She often sits in the crow's nest on top of the main mast. The main mast of the ship is supported by shrouds, which run from the top of the mast to the hull of the boat. Okay, so if we're looking at this diagram, they've kind of already given it to us. The crow's nest is up here, and these shrouds, right, go from the main mast all the way down to the hull. Okay, that's what they're talking about here. So they've kind of given us a diagram. Okay, to make sure that the mast is properly supported, the shroud must be attached to the top of the mast at an angle of depression of 78 degrees. Right, so what they're showing here is what the ideal angle is supposed to be, of 78 degrees. We know from the question here that the mast of the tall ship is 150 feet tall, and Lori notices that the shroud is secured 22 feet from the base of the mast, right? So this is the mast coming straight down, and the shroud is 22 feet across, okay? Does the shroud form the correct angle of depression to support the mast? If not, how far should it be placed? All right, so let's kind of, get rid of all the extras that we need there from that boat image and just kind of take out the necessary information, okay, to draw that triangle. So one of the first things was the fact that we knew that the mast had a height of 150 feet, okay? We knew that. We also know from the question here, right, that Lori notices that the shroud is secured 22 feet from the base of the mast, okay? So there's the base of our mast, and it seems as though the shroud was connected here 22 feet away, okay? This would be our right angle. This would be our kind of triangle. Now, what they're saying in the question is that in order for this to be safely secured, the angle of depression, meaning this angle here, should be 78 degrees. But the thing is, we don't actually know that, right? They're saying it should be. We're being asked to say, well, given that the mast is 150 and it's secured 22 feet away, does this match? Okay? And, that's the thing we need to try and find. So we're essentially trying to find this angle. What is it? Is it 78? Then it's good. If it's not, well, then let's fix it. Okay? So that's kind of our theta, right? So again, you can picture this as that upside down triangle now, right? Kind of create a rectangle where, again, this and this will be the same. So that's still 150 feet. And then that distance here is 22 feet. Okay? And then if we do that, we're looking for that missing angle, right? So looking for that missing angle, there's opposite, right? This would be my opposite side length, and this would be considered my adjacent side length. Okay? So that would mean, again, using tan. Okay, so again, I can just kind of erase that section of it. Okay? So this would be a tan. So tan of the angle is equal to the opposite divided by the adjacent. The angle is what's missing right now, but we do have the side lengths for opposite being 150 and adjacent being 22. Okay, so I can divide this to get that ratio, right? So 150 divided by 22. So we get that tan of theta is equal to 6.8181818, and keeps going. Okay, so then remember we talked about this in the review. To solve for a missing angle, right, we do the inverse trig ratio. So we take the tan inverse of both sides, and that cancels out the tan, leaving you with just theta, right? So theta will equal tan inverse of 6.81818, right? So tan inverse of that value, and we get a value here of 81.6, so let's call that 82 degrees, right? So with a mast of 150 feet and the shroud being placed 22 feet away, the angle of depression is actually 82 degrees, but it's supposed to be 78, right? So the first part of our question is no, it's not secured to the right thing. And the second part of the question asks us, right, so the first part, does the shroud form the correct angle of depression to support the mast? If not, determine how far, right? So it doesn't. So now determine how far from the base of the mast the shroud should be secured in order to make the correct angle. Okay, so with this one, right, we can change how far away we place the shroud. Okay, we can't change the height of the mast. Okay, so again, we kind of redraw this a little bit. Okay, so we cannot change the height of the mast. That has to stay at 150 feet. But we can make sure that this angle of depression, okay, is in fact 78 degrees. Okay, and in doing that, I don't like that drawing. Okay, and in making sure that that's 78 degrees, we can figure out what this horizontal distance actually should be. Okay, so again, if you kind of think of this as the upside down triangle here, right, this is still 150 feet. Okay, this is the value that we're solving for, and now we're using that angle. So it's once again a tan ratio, because there's your angle that you have now. Opposite side length is the mast, and the adjacent side length is the horizontal distance that you're solving for, right? So basically just inverting that triangle. So once again, it's that tan of 78 degrees is equal to the opposite 150 divided by the adjacent x. Okay? When you're solving anything that involves like trig ratios like this, right? If you're using something with a fraction to help solve anything with a fraction, multiply both sides by the denominator. The denominator here is x, so you multiply both sides by x. That cancels, so that now gives you x times tan of 78 degrees is equal to 150, okay? Now you want x by itself, it's being multiplied by tan of 78, so to do the opposite there, you divide both sides by tan of 78, right? So that's what x is going to equal, right? So x will equal 150 divided by tan of 78 degrees, and you get a value of 31.9 degree, actually we're solving for side length, feet, so let's call it 32 feet, okay? So really that shroud should be placed 32 feet away from the base of the mast, not the 22 feet that it says in the question, okay? So again, then if you're not able to watch the videos, obviously you just want to come back to this, the answers are here, explaining it, but away you go, okay? Right, so what I've got for you to practice now is just I picked out some of the questions from the textbook. They're all from kind of different pages, so it just made sense to kind of copy and paste them into a single document, and they all just involve these types of angles of elevation and depression. So either the question mentions angle of elevation and depression, and you have to set up the question using that information, or it asks you to find the angle of elevation or depression, but that's really what you're doing is just with the trig, okay?